Determine the derivative of the following functions. This is another example of just progression of putting functions inside of functions inside of functions. So if you take the derivative of this thing here, it's going to be d by dx. So it'll be dy by dx is equal to, that's just going to be cosine. Cosine of x. How do I know that? Well, let's look at my little sheet here. My little formula sheet. Derivative of sine is cosine. Okay. Now we're going to take the derivative of, a polynomial. There's a sine function inside, but it doesn't matter. The outside is a polynomial. It matches this. X to the power of n, some constant, something with x in it, some function to the power of a constant with a coefficient. That's a polynomial, it's a power function. So it's going to be dy by dx is equal to, well, 2 comes down, so it's going to be 2. Everything inside stays exactly the same, to the power of 1, times the derivative of the inside, which will be cosine of x. Okay? And you can see that right there is right there. Okay? And I can guarantee when we do this one, all this will be attacked on the back end of it. But d by dx, here we go, so dy by dx on this side. And now this guy here, oh, we have a cosine. I know what derivative of cosine, it's right here. It says negative sine. Negative sine of everything on the inside. So sine x, there, squared, bracket closed, times the derivative of the inside, which is now going to be just that thing. So it's going to be 2, comes down, 2 sine of x to the power of 1. And then times the derivative of the inside of the polynomial, which is going to be sine, which is going to be cosine. Cosine of x. Okay, and if those are x squared here, we take the derivative of the inside there again. But you can see that this is just the same thing. And then also this guy here comes from there.